estimation, and another one is glucose 6-phosphate estimation. Glucose 6-phosphate dehydrogenase estimation. Okay. So first let us see what is HB. What is the normal value of HB? 12 to 16 grams per deciliter. Very good. So methods of estimation of hemoglobin. So there are multiple methods. Actually, students, there are multiple types of hemoglobin also. Do you know that? Hemoglobin fetal hemoglobin, hemoglobin adult, HbS. What is HbS? That is sickle cell anemia. So various types of hemoglobin are there. We are going to detect adult hemoglobin. We are not going to detect fetal or sickle. Okay. For them, other methods are there. We are going with only adult hemoglobin estimation. Is it clear? So this adult hemoglobin estimation can be done in various methods. So there are various forms of hemoglobin. I will tell you. Hemoglobin in association with oxygen, that is called oxyhemoglobin. Then hemoglobin with carbon dioxide. Okay, this is carboxyhemoglobin. This will be detected in the form of cyanohemoglobin, HB. Okay, method is with cyanohemoglobin. Okay, now the methods include, one is colorimetric method. Colorimetric method. So here we are checking the color. Okay, applying this Lambert's law. The higher the intensity of color, the directly proportional to the concentration of the hemoglobin. So that is the colorimetric method. Ideally performed for cyanohemoglobin method. Cyanohemoglobin method is colorimetric method. Okay. Then another one is visual method. Visual method or manual method. Okay. Manual method. So in this manual method, we will compare. We will use a comparator, color comparator, by using a specialized apparatus called a Sahli's apparatus. Sahli's apparatus. So this is a very simple method that has been adopted by a scientist called Sahli. Hence it is called Sahli's hemoglobin method. Okay, a visual manual method. The third one is automatic methods. Okay. So we have many automatic methods of identifying hemoglobin. Okay, this machine can give hemoglobin value automatically. So there are electric impedance, there are various principles of detecting. So they are called as automatic methods. Okay. So today we are discussing about this one. Okay, Sahli's method. So in the Sahli's method, what we have various components. So this is the Sahli's, you already know this thing, right? Sahli's comparator. There is a standard color comparator here on both the sides. Then we have a specialized pipette called a Sahli's pipette or Sahli's test tube. So you will keep Sahli's test tube here. So in this there are a reading at the bottom. Okay. Bottom you have a reading of 2. So bottom it will start with reading 2. Up to 2 mark you need to take n by 10 HCl. Okay. So in this you have a test tube. Okay, this is a specialized Sahli's tube. In this Sahli's tube, up to bottom 2 mark, you need to take n by 10 HCl. Take n by 10 HCl, that is an acid. Okay, hydrochloric acid. So we have taken acid, then we will add 20 microliters. We are going to add 20 microliters of blood sample. We are adding 20 microliters of blood sample. So we add a blood sample. Okay. Now it has readings here like this. Okay. Up to 140% we have readings. Okay. So what we are going to do is, to this tube, since acid reacted with hemoglobin, that will give a reaction. Okay. N by 10 HCl plus Hb results in a complex called acid haematine. Acid haematine formation. Acid haematine. Okay, this acid haematine is a brown color complex. This is a brown color complex. That means we will develop a brownish color solution upon adding blood to it. Okay. After adding it, you need to wait for 10 minutes. After 10 minutes, what you have to do is, now you got a brown color solution, right? Now to it, you will start adding distilled water drop by drop. You are going to add distilled water, so you are dissolving it. Okay, you are dissolving it to make it lighter. Now the solution will become pale. The solution should become pale to an extent where the color should match with the comparator color. There is a standard comparator color. There is a comparator, okay? This color should match with this color. Until this color matches with this color, you need to add the distilled water. Drop by drop, you need to add distilled water and you need to check. In between, there is a mixing rod. I don't know whether it is here or not. There is a mixing. I think we lost it. No? Students usually they will break. Yeah, there is a mixing rod. So there is a mixing rod. So in between with this, with the help of mixing rod, you will mix the sample evenly. Okay? So this is mixing rod. So you will mix it until this color matches with this color. Okay? At one point, when you are adding distilled water, color matches whatever the upper level. That reading will be your HB reading. That's it, simple. Okay? It is not gold standard method. It is not so accurate, but this will give almost precise results. Okay? This is a cheap, cost-effective, rapid method of estimating hemoglobin. Commonly, we will adopt this method only for hemoglobin estimation. Okay? So this is all about hemoglobin estimation with the Sahli's method. Keep in mind, this is called a Sahli's method.
Sir, I didn't understand the acid.
Huh?
The acid, I didn't understand the acid. Yeah, the opposite. No, the
acid hematine you were saying.
Yeah, the formation since the acid addition to the formation, I didn't understand.
Yeah. Listen. So first I already took acid, then I added a drop of blood. Okay. Now blood became acidic. Okay, hemoglobin became an acidified hemoglobin called acid hematine. That will be in deep brown color. It's in very thick brown color. Now what we are doing, we are dissolving the brown color with distilled water until the brown color matches with this brown color. Actually this is light brown color we can say. Until this dark brown turns to this standard light brown, we are dissolving the sample with water. At one particular point, this will look like same color. Both of them look same color, and that will be your level of hemoglobin. So, yeah, this scientist did a really interesting statistical standardizations actually. How he standardized this color means he has done pilot studies on multiple patients. Then he understood a normal healthy hemoglobin must have this particular color. So he has done some surveys and he has standardized this color. And we are using, we are just comparing our test with this color. Whatever level we got, that will be hemoglobin level. Not so accurate actually. There are still some limitations, but this is easy. Okay, cheap, easy to do. That's the idea. Okay. At the end of the day, we are trying to reach to the, to the most interior healthcare facility. Okay. When you think in a villages, there won't be any trained staff, and we cannot give complex tests to them. So we are trying our level best to keep the test as simple as we can, so they can do the test in their lab, and the people will get benefits of quality healthcare. Okay. This is all about Sahli's. Any more doubts in Sahli's method? Right? So okay. I said 20 microliters of blood sample, right? So Sahli's has their own 20 microliter pipette. Okay. So there is upper marking. When you color blood up to upper marking, that will be 20 microliters. You need to do mouth pipetting or you do manual pipetting and color up to 20 microliters of blood sample. Okay. That's it. Yeah. Then coming to the G6PD. The next test is glucose 6-phosphate dehydrogenase test. Keep in mind, this test is performed in biochemistry. I agree. Okay. In biochemistry, they are purely their agenda is to understand the levels of G6PD. But in hematology, why we are doing G6PD? It's a biochemical thing, right? Yeah. In hematology, we are detecting G6PD because this G6PD will release glucose 6-phosphate actually gluconate, that is an acid, glucose 6-phosphate gluconate plus NADPH plus H plus. This NADPH is important for glucothione. This glucothione is essential for maintaining the cell membrane of the red blood cell. Red blood cell membrane strength. Okay, the cell membrane strength is maintained by a substitute product, that is glucothione. Glucothione is produced by NADPH. NADPH is came from this enzyme. Okay, so absence of this enzyme results in absence of this. Absence of this results in absence of this. Absence of this results in destruction of the cell membrane, resulting in bite cells and hemolysis. Simply we can say red blood cell has a cover. That cover plastic material is glucothione. The glucothione is made by a machine, that is G6PD. When the machine not working, I cannot make the cover. When there is no cover, red blood cell might blast like a balloon. Okay, that blasted or partially hemolyzed cells are called bite cells. So in order to check this anemia, this hemolytic anemia, we are checking the G6PD levels in the patient. Okay, this is a complete indirect test. Rather than detection of this one, we will do some smart tricks. Listen the trick. I will measure this product. The number of, if G6PD is 20 molecules, I must get 20 molecules of NADPH. So they are directly proportional. The level of G6PD is directly proportional to its substrate, that is NADPH. NADPH is directly proportional to G6PD. What I am going to detect is, I will detect NADPH. I am going to measure NADPH levels. NADPH levels are directly proportional to G6PD. Is it clear? Yeah. So see now, I will write the principle of this test. So suppose we have a patient sample. We have the patient blood drop. Okay. What is my agenda in the blood drop? In this patient sample, I want to check his enzyme. What enzyme? Glucose 6-phosphate dehydrogenase. How I will check this enzyme means, I will take a cellulose paper. Okay, I will take a filter paper. I took a filter paper. Then I added a drop of blood on this filter paper. So the drop is here. A drop of blood has been added to the filter paper. Now, I will suspend this filter paper in a solution. I will suspend this filter paper in a solution containing, this solution has that enzyme substrates. What are the, where does this enzyme works? This enzyme works on NADPH. Okay. So what I will do is, in this solution, there are glucose 6-phosphate plus NADP. I added glucose 6-phosphate and NADP in the solution. When there is enzyme in the patient sample, this enzyme must break my NADP into glucose 6-phosphate gluconate, an acid form, plus NADPH plus H plus. I am detecting this one. Okay, it will release NADPH H plus things, right? It will release some ions, NADPH. This will be detected by fluorescent technique. I will add some fluorescent molecules. Fluorescent molecules means they will emit some color. Okay, this NADPH will be binded with some fluorofluor. That will be, ideally it will be a sodium isothiocyanate. I don't want to make it complicated. There is some color substrate. That color substrate will be binded to this NADPH. That is called fluorophore. PHRE, fluorophore. This fluorophore can be detected under UV light. When you hit some UV light on this solution, you will get some bright green color. Okay, bright green color can be observed. The intensity of green color is directly proportional to the levels of G6PD in the patient blood sample. That's it. Okay. We are just going with very indirect method just to confirm whether patient has a G6PD or not. That's it. It's just a qualitative test. It's not a quantitative test. We are not going to measure the quantity of G6PD. We are just seeing whether it is present or absent. That's it. Right? Presence or absent is called as qualitative. When you are checking the the volume, then that will be a quantitative. I hope you know these things, right? Yeah. That's it. So write down the normal levels of G6PD. In a normal adult, the G6PD levels are normal G6PD levels are 1 second. I made a blunder mistake with this. I haven't got normal values here. Anyway, I will give you. Wait. 1 second. Everyone, write down the normal value in your records also, okay? I forgot to add in the lab manual. There is no mistake there. Normal values of G6PD. The normal value of G6PD is 4 to 15 units per gram of hemoglobin. 4 to 15 units per gram of hemoglobin. This is the normal value of G6PD in adults. Okay, it is an average value. 4 to 15 units per gram hemoglobin. Okay, hemoglobin is always in grams, not milligrams. Okay, that's it. Is it clear? Any doubts in this test? This reaction, I will make it very simple. So we have an enzyme. What is that enzyme? G6PD. Okay, this enzyme works on glucose 6-phosphate. Okay, in the presence of glucose 6-phosphate is the substrate of this enzyme. Okay, it also needs a cofactor, that is NADPH. NADP plus. Okay, these two are the substrates of this enzyme. Okay, now this enzyme reacted on them. This enzyme reacted on these two substrates and it is producing the two products. They are, one is glucose 6-phosphate gluconate. This is an acid form of G6PD. Okay, and also it released one more product, that is NADPH plus H plus. This is a free form of NADPH. Okay, now we are detecting this one actually. We are detecting these levels and these levels are directly proportional to these enzyme levels. That's it. That is the idea of this test. Okay, this will be detected with some fluorophore. We are adding some coloring substance and that fluorophore will be detected under UV light. Okay, or this test, how it looks means, I will take a piece of paper, I will give a drop of blood on it, I will suspend this paper in a solution. Solution has these two things. Okay, enzyme reacted. Then after 10 minutes or after 1 hour, I will dry out the paper and I will measure I will keep paper under UV light. Under UV light, I will get some color. It will emit some color. That color is directly proportional to G6PD. Okay, a simple test. Very less cost only, maybe 100 rupees around. So the depends on kit also. Anyway, clear, right? That is G6PD. What is the significance of G6PD? There is a type of anemia called G6PD deficiency anemia, in which I need to tell one more term, that is differential diagnosis. What is the meaning of differential diagnosis? You got one value of this test and you need to cross verify this value. What will be the another test you can perform to cross verify G6PD deficiency? Is there any other test to confirm G6PD? This test we performed, we came to know that levels are less than 2. Okay, rather than 4, less than 2 units per gram of hemoglobin. How you will cross verify this? That cross verification is called as differential tests. The other test we can perform is very simple. Take the patient's blood sample, make a smear. In the smear, in the peripheral blood smear, we need to identify one type of red blood cell. What is that cell? Bite cells. That's it. Presence of bite cells will confirm this test. Okay? This test must come positive. Then it indicates it is a G6PD deficiency candidate. You know why we are concerned with all these things? These are rare anemias, but they are usually asymptomatic. They will be misdiagnosed. These patients will be misdiagnosed thinking they have a normal anemia, and doctor will give many vitamin B12 supplementations, but still patient will be very weak. So then we will go for investigations. Okay, see, anemia, the reasons of getting anemia, many things are there, right? There are multiple reasons to get anemia. We have seen that sickle cell disorders, G6PD issues, Fanconi anemia, bone marrow issues, dietary issues, intrinsic factor issues, absorption issues, or some hormonal issues, erythropoietin issue, thyroid issues. See, many reasons lead to anemias. And when we are not treating anemia on time, patient might die because complications. Okay. Yeah, I need not to say much. You already know. Brain without oxygen for 3 minutes is sufficient to be in coma. Brain without oxygen for 8 minutes, you will be dead permanently. You will have heartbeat, but you won't be alive. You can't restore brain. Right? 70% of oxygen we breathe will be consumed by the brain. You know that? Only 30% is sufficient for body. 70% for brain. That means it's a very, very energy demanding organ. That's it, students. No more doubts, right? Yeah, that's it. Go through the content and there will be a quiz now. And that marks will be directly added into the performance sheet. Go through this once.